So today we'll deal with physical, chemical and biological characteristics of water. So when we speak of physical characteristics are those characteristics of water which can be directly identified by human beings through his or her five senses. For example, first physical characteristic is color. Color can be identified by your naked eye. Pure water is colorless. Then turbidity. Turbidity can be identified by naked eye because pure water is clear and do not absorb light. And the colloidal particles within water which remain in the suspended matter can be easily seen by your naked eye. Then another physical characteristics is taste and odor. Pure water is always tasteless and odorless. Next comes that can be felt with temperature, form, then conductivity, total dissolved solids of water, etc. are physical characteristics. So temperature of water that can be felt with your hand. If you touch water, you will feel the warmth if the temperature is high. And how does temperature rise in water is due to effluents that are coming out from industries, and especially for coolants. Water is a cooling agent in nuclear reactors, and the water, after circulated within the area to absorb the temperature, it is put out into river bodies or water bodies. Again, the lather forming soap, if it is present in water, it creates foam, FOAM, foam. Then ionic particles which are present inside water will create conductivity. So all these things are the physical characteristics of water, and they create they can be sensed by the five senses. Now when we speak of temperature in detail, it is not directly used to evaluate the potability of water, because at different temperatures water can be drunk, or we drink water at different higher temperatures. So the potability of water is not directly getting affected by temperature. But in natural water systems, when temperature rises, DO decreases or dissolved oxygen decreases, because it gets evolved out of the water and it comes out as oxygen. Now, rise in temperature also increases the growth of aquatic microorganisms, and hence, when the number of organisms increase, they consume more of the oxygen that is dissolved, and dissolved oxygen decreases. So this creates a kind of pollution effect. So temperature rise affects in two ways. One is the dissolved oxygen gets evolved out of the water and escapes out of water as oxygen in the gaseous form. That is first problem. Second, due to temperature changes, the increase in growth of microorganisms will result in the increased usage of DA for respiration. The dissolved oxygen decrease occurs. Next is foam, FOAM, foam. Foam in water is due to forming substances like detergents and soaps, and it will get dissolved in water, and it is dangerous because it will create anaerobic condition. Because dissolved oxygen is not the ability of dissolution of oxygen into water is affected by foam, because foam is present in the surface of the water, and the surface is cut off. The interaction of the air with water is cut off due to foam, or the lather that comes on top of water bodies will cut off the contact of water body with air or oxygen. So some foaming substances can be toxic to consumers also. Next is conductivity. Now, due to the presence of ionizable inorganic compounds, or due to presence of ions, conductivity occurs, and pure water has low conductance. So that is it. And the next comes total dissolved solids. Now, if water is filtered to remove suspended solids, the remaining solid in the water indicates total dissolved solid. Now, dissolved solid may be organic or inorganic, because dissolved solid from animal and plant waste can occur, or it can be from inorganic areas also. So if dissolved solid exceeds 300 mg per liter, it adversely affects living organisms and industrial products. Now next is chemical parameters of water. So far we discussed physical parameters, and now comes chemical parameters of water. Now when we think of chemical parameters, chloride ion is a parameter that will affect water, because when it is normal and in low concentration it is not a problem, but it reaches, chloride ions reaches water through urine, sewage, contaminated water, etc. So it gives a salty taste and also corrodes pipelines of water. Normally 150 milligram per liter of chloride ion is harmless, but above that it is harmful. So maximum permissible limit for drinking water is 200 mg per liter in the case of chloride ions. Next important factor is ammonia. In water, ammonia comes from decomposition of organic matter like protein, amino acids, etc. That is, organic matter is getting decomposed and they form ammonia. That is, during the decomposition, during the breaking down of complex molecules to simpler ones, as a byproduct, ammonia gets formed and it becomes a part of water. In water, ammonia is first oxidized into nitrate. Now, what chemical reactions occur in water for ammonia is that it is chemically oxidized into nitrite and then into nitrate. Now, therefore, the measuring, in order to understand or in order to measure the concentration of ammonia in water, nitrite and nitrate, we can predict. Now the presence of the amount of nitrite and nitrate are studied, and the presence of nitrite and nitrate indicates the presence of ammonia in water, or we can understand that water is getting contaminated by ammonia when we understand, when you find out the presence of nitrite and nitrate. It is because ammonia is getting converted to nitrite and then into nitrate. Then concentration of ammonia in groundwater system is usually 3 mg per liter. If the concentration is greater than 50 mg per liter, it gives characteristic taste and odor. So a particular taste and particular odor is getting created. That is known as characteristic taste and odor. So from that we can identify the presence of ammonia. Then nitrite acetone, ammonia is converted first into nitrite and then into nitrate. Now the nitrite presence is from that we can understand that now nitrite is something very unstable, and very unstable intermediate which is formed during conversion of ammonia to nitrate. So in aerobic condition, nitrite is greater in drinking water, and it brings serious health hazard to consumers. If the amount of nitrite is very high, it brings serious health hazards. Disease caused by high concentration of nitrite in infants is known as blue baby syndrome. And level of nitrite in drinking water should not exceed 3 mg per liter. Now, after the formation of nitrite, I told you nitrite is very unstable. So they are converted to nitrates. So it is most stable oxidized form of nitrogen is nitrate, and in water nitrate comes from organic matter decomposition and from atmospheric nitrogen fixation. Now like nitrate should not exceed 3 mg per liter in drinking water. Concentration of nitrate promotes growth of aquatic plants and creates eutrophication. And due to eutrophication, again dissolved oxygen gets consumed. Now nitrate is a manure, and the presence of nitrates will proliferate the growth of microbial plants, and microbial plants will use oxygen for respiration, and it will create a condition known as eutrophication. Now phosphate is the next thing that is getting into water, creating pollution, and in water phosphate is present as H2PO4, and that is a polyphosphate, and it will not affect human beings, but it comes from agri waste and sewage and from industrial effluent, and it is not a toxic to human beings, but high concentration of the same will create the condition of eutrophication. That is, phosphates will help the growth of or proliferate the growth of microbial plants, and they will use dissolved oxygen. Next is hardness. Hardness is due to dissolved calcium and magnesium. Temporary hardness is due to carbonate and bicarbonate of calcium and magnesium, and permanent hardness is due to chloride and sulfate of calcium and magnesium. The water is classified on the basis of calcium carbonate concentration as soft water, moderately hard water, and very hard water. Now, next important factor that you have to understand is BOD and or biological oxygen demand. Now, biological oxygen demand is the oxygen demand that is created due to biological processes. That is, oxygen required by living organisms for oxidization of biodegradable organic matters present in water under aerobic condition and is known as BOD. That is, the oxygen required by living organisms for oxidation of biodegradable organic matters present in water under aerobic condition is known as BOD. That is, the amount of oxygen that is getting used during conversion of complex molecules to simpler ones biologically. That is it. Now, BOD is a direct measurement of quantity of oxygen needed for biodegradation of organic matter into indirect measurement of quantity of biodegradable organic matter in water. Now, when biodegradable organic matter is added in water, microorganism utilizes dissolved oxygen to oxidize organic matter. Now, if the rate of consumption of oxygen during biodegradation is greater than solubilization of atmospheric oxygen into water, the level of dissolved oxygen gradually decreases. Now, if organic matter content is very high, complete loss of dissolved oxygen occurs, and this creates anaerobic condition in water. High value of BOD indicates high degrees of water pollution. Next is chemical oxygen demand. Chemical oxygen demand, COD, is amount of oxygen needed for oxidation of organic matter present in water by strong chemical oxidizing agents, that is chemically in nature, and it is, for example, it is K2Cr2O7. Now, COD measurement is particularly valuable to determine amount of organic matter in water which contains toxic or antimicrobial chemicals. K2Cr2O7 is a strong oxidizing agent, that is potassium dichromate. It's a strong oxidizing agent, and it oxidizes both biodegradable and non-biodegradable organic matters. Therefore, the value of COD is always greater than BOD for particular water sample. COD gives amount of total organic matter present in water. Next is dissolved oxygen. Dissolved oxygen is the oxygen that is soluble in water, and or the water that is dissolved in water. This oxygen that is dissolved in water. It is a source of oxygen for aquatic organisms like fishes and aerobic bacteria. If DO is absent, aquatic organisms cannot survive. It is affected by many factors like temperature, organic matter content, etc. So, solubility of oxygen in water decreases with increase in temperature of water. And secondly, the high temperature promotes growth and activity of aquatic microorganisms so that they consume oxygen faster. If organic content is very high, microorganisms utilizes dissolved oxygen for its oxidation, causing depletion of dissolved oxygen level. Last, we will speak of pH. The presence of ammonia, OH negative, Ca++, Mg++, etc. makes water alkaline. Water becomes acidic due to presence of dissolved acids and carbon dioxide. So these are the characteristics of water.